Hello, welcome back to the introduction to data science for business. I'm Professor Sean Watts, and today is the third session where we're going to be talking about some slides. What really is data science? And in addition to this, I'm going to be presenting two small assignments just to make sure the key concepts are understood. Again, my contacts are here. We're talking about data science, and a big part of data science, at least at the introductory level, is the idea of how we can use analytics and insights programs with things like social media. But we're going to be able to go beyond that today. So what really is data science? It's a variety of different things. It's considered the sexiest job of the 21st century. You're going to learn important elements of data science. In this class, you'll be introduced to the principles, practices, and tools that make data science the powerful medium for critical insight in business and research. You'll have a solid foundation for future learning and applications in your work. With data science, you can do what you want and do it better because it's not just your idea that you're working with. Soon you'll have data, and the more data or the bigger data you work with, the better the results you will have because you're processing details scientifically. So, what really is data science? Data science, it's not about making complicated models. It's not about making awesome visualizations, and it's not about coding or hacking or computer programming. Data science is about using data to create as much impact as possible for you and your company. Now, to do those things, you'll need some tools like sometimes complicated models or data visualizations or writing code, but not always. Sometimes simple things just like an Excel file will be able to provide enough data for you to have a evaluation and be able to come to certain conclusions. As a data scientist, your job is to solve real company problems using the data, and what kinds of tools you use is not really important. People don't really care. If you use the advanced statistical programs, great. If you use advanced computer programming, great, but you don't need to. We're going to be going through, and as I said, simple programs like Microsoft Excel will be sufficient to do the basics in data science. So data comes from the world's uses of technology. Customers' usage creates valuable data, showing what people like, dislike, important locations, times, and much, much more. As we see here with Facebook, there is a variety of things that Facebook is collecting about every user now, not just the idea of what you like or you dislike, or now what you're neutral to, but of course, if you're sharing things, that means you liked it enough to share it. And if you comment, that means you like it a lot enough to try to get people to talk back. So Facebook's dislike button will give us a new dimension and complete the spectrum of sentiment measurement. What we're talking about is important because in 2016, several years ago, Facebook was so advanced they could identify almost every voter in the United States, their preference for who they were going to vote for. And the details were able to be downloaded and fed to other companies many years ago, to the point that that company was able to sway elections and help certain candidates win. It's not just in the United States, it's in several different countries. Some people were saying Brexit, or in Kenya, or in Myanmar, and South America, various areas all over the world. But yes, also in the United States, where Facebook had one of the final slides I'm going to be talking about is your control of your data is very important. Facebook didn't have complete or proper control, and they were fined billions of dollars. I believe it was over $5 billion Facebook had to pay because their data was managed through data science Some people say ideally for certain candidates, but improperly in other people's views. So, what decision-making techniques have contributed to your most successful projects? Some people say customer feedback, experimentation, testing, giving the product to your customers, getting feedback or testing their results, data analysis, of course, cost benefit, pros and cons. There's a lot of different decision making techniques that can be used to collect data or survey. This is generally just a survey. You survey customers, you survey people in your environment. As long as you survey correctly, that data can tell you incredible details. So data comes from the world's usage of technology. As I said, customers' usage creates valuable data, showing what people like, dislike, important locations, times, and more. Impact from the data can be in the form of multiple things. It could be in the form of insights, in the form of data products, or in the form of product recommendations for a company. In the first few classes, I was trying to simplify details, showing you that data science is often associated with the big data, and big data started to grow in 1999, in the year 2000, when people were thinking all of my data is saved and in files, and if it was saved as 1998, no problem. 1999, no problem. But then the next year, all of the data is going to go to 00, and they thought that the data was going to be lost. So big data was developed for the world's international companies, multinational companies, and they have developed a lot. And with the data that they developed, they found out that they could get better business results, understanding not only what is happening with their company, what is happening with their ratings of their business, their products and services, but from the customers and from the environment, or even from their suppliers. All of that was being controlled. So please make sure that you're aware of those details, starting with big data. But in addition to that, it was also and continues to be also very popular with the free versions, while the MIS, the Management Information Systems, or Employee Resource ERP systems, sometimes cost many millions of dollars for big companies to use. Eventually, Google came out with their own free version, as did Facebook and most other social media. So now you can get Google Analytics or Google Insights and YouTube Insights and Analytics. Going through those provides you with the similar types of information, this data science that allows you to be much more successful. As we see here, even Netflix is also using it. It can identify what people in the world are watching, what people in your location are watching, and share some of those details. It can also identify certain characteristics based on who you tell them you are, what is your background, what is your age, what is your avatar. Based on those details, it can share similar movies. So data science can definitely increase business performance. So now to use the data and impact the company, then you need management experience or tools like making complicated models, or data visualization, or writing code. But essentially, as a data scientist, your job is just to solve real company problems using data, using facts. And again, what kind of tools you use is not important, as long as you're doing it properly. So there's a lot of misunderstandings about data science, especially in YouTube. It's there because there's misalignments between what's popular to talk about and the needed in the industry. So I want to be clear. I am a PhD with a doctorate of international management information systems, working internationally for decades as a professor in this international management and data sciences. Data science, big data, analytics, and insights are a core of my focus, and these are growing. They're growing for sure. They're growing around the world in usage, and they're growing in importance daily, much more than most people understand. It's going to be shocking for people that actually get to identify how much the data is growing. So success going forward with almost any business and almost any activity depends on this data science for business, how you're managing yourself, how you're managing your product and services with your companies. It's going to be crucial. The top companies, whether they're multinational, huge conglomerates, or small individual businesses, these top companies really emphasize usage of data to improve their products, services, and overall business. It is essential. Please understand these details. So this is my take on data science, and it's collected from various sources. I generally prefer academic journals, especially peer-reviewed academic journals like Web of Science or Scopus journals, but I get a bunch of information from various sources, even YouTube, Gartner reports, influencers all over the place. And this presentation today is a collection of information from all over the place. So again, what I'm showing you is data science. It is computer science and data mining originally. That's what some people were talking about, but it's much more than that now. Before data science, we popularized the term data mining in an article from data mining to knowledge discovery in databases. It was in 1996 in which it referred to the overall process of discovering useful info from data. That whole concept of discovering useful information, it is exploding. It's becoming very, very important. It's the more you understand about it, the more you will want to know about it, and the more you will realize it's valuable. In 2001, Bill Cleveland wanted to bring data mining to another level. He did it by combining computer science with data mining, but that was over 20 years ago. Today, it's much more than just a computer science, and we're going to be getting into that. So if we talk at the beginning, basically, Bill made statistics a lot more technical, which he believed would expand the possibilities of data mining and produce a powerful force for innovation. That was basically the beginning of Web 2.0. Now you can take advantage of computer power for statistics, and he called this combination data science. But you don't always need to use statistics to do the data science. I'll be talking about that later. Around this time, this is when Web 2.0 emerged, when websites are no longer just digital pamphlets, but a medium for people to sign up and add information and share details, share experiences amongst millions of other people. And as one person signs onto a website and shares thousands of their details, and then each one of their friends sees and shares thousands of details, you can understand how it's growing exponentially. And we've gone well beyond Web 2.0. We're at Web 3 and beyond, where the web is creating its own information now. So back in 2003, simple details like MySpace in 2003 developed with the Web 2.0. Shortly thereafter, in 2004, we had development of Facebook and then YouTube in 2005. Facebook's one of the major forces that brought the internet into the highly participatory phase, full of user-generated content known as Web 2.0, and it has remained controversial because while some people like to use facts as a basis of things, other people may like to just troll people or provide misinformation. So in addition to allowing misinformation online and fake accounts to proliferate, Facebook has drawn criticism both for selling its users' data and for failing to adequately protect it in the past. As I said, they were fined, I believe it was over $5 billion for just the one case with Cambridge Analytica, and there are still issues going on. After that, even 2005, YouTube started, and we can now interact with many of these different websites. and make lots of data. Everybody can upload your own videos and start watching other people's details. All of that is data. Anywhere you go and you watch it is also data. And then there's lots of studies about that data everywhere. Not just making the videos, but also sharing them and putting on a like or GIFs or emoticons with it, meaning we can contribute, we can post comments, like it, upload it, share it, leaving our footprint or fingerprint in the internet helps to create the ecosystem that most people love. But it is mind-boggling how much data is out there. There's so much data, it became too much for most people to handle on their own, so it was called big data. And now we're using the technology in order to go through these details and work with this huge amount of information. This huge amount of information, or the big data, opened a world of possibilities in finding insights. So if we know what anybody is typing online, what anybody is doing with their cell phone, showing where's their location or their GPS, we can get so much information and easy information about what they like and what they don't like. That is very valuable to companies. The companies know what customers like now and what they don't like. So it's not just making a new product and hoping customers are going to like it. Companies now can identify what customers want and simply give it to them. The whole process of marketing and management has flipped because of this big data. And data science is the art and the science of being able to manage this. So data opened a world of possibilities in finding insights using data, but it also meant that the simplest questions require sophisticated data infrastructure just to support the handling of the data. And that's what I'm showing here, this idea of data nodes on local disks with backup details. So we need sometimes parallel computing technology like MapReduce or Hadoop or Spark. This idea, it's growing. It has grown from several years ago. Each month, each day, the technology is growing incredibly fast. As we see here, big data, as I said, generally started in 1998, 1999, before the 00 years, the Y2K issues. But big data started then, and it has been exploding almost exponentially since around 2010. And the same thing is happening with data science. So the big data was growing a lot in around 2010, and now 10 years have gone by since then, and people are starting to realize the importance of it, and now it's catching on with everybody. So please be aware that almost everybody, and definitely the big companies, are aware of its value and aware of its importance. So make sure you're not left behind. The rise of big data in 2010 sparked the rise of data science to support the needs of businesses to draw insights from their massive unstructured data sets. And it's not just my idea. It is proven. It is well researched. And this is from research journals. From the Journal of Data Science, an international journal devoted to applications of statistical methods. What it was saying was the definition. Almost everything has something to do with data, whether it's collecting data or analyzing data, modeling data, yet the most important part is its applications. And there's many different types of applications. So this Journal of Data Science described it, and this alone is starting to grow in importance. The other researchers or professors are learning of these details, and they are promoting it to the classes. Their students are promoting it to companies. The companies are promoting it. It is growing incredibly fast. Here's another article, a slightly different type of article, but it's saying the same type of thing. In 2010, with this new abundance of data, it made it possible to train machines with data-driven approach rather than the knowledge-driven approach. All the theoretical papers about recurring neural networks support vector machines became feasible. This idea that artificial intelligence is a force for good, it's growing enormously. And obviously, when machines are growing with artificial intelligence and machine learning, then they are making their own data. So it's not just data that I put into a computer system and you type into a computer system. It's also the data that follows us wherever we go. It's also the data of who we are close to and what type of restaurants or businesses we are near. But at the same time, our own computers are creating data on their own. And so the amount of data is growing. So the science to understand it is growing in importance. So here we can see a story talking about how we can meet the artificial intelligence that IBM research is teaching to debate against people. So computers are not just smart and they're not just becoming intelligent now, but many years ago, I had students in my class that actually showed a simple version of this. IBM with their IBM Watson is one of the most advanced, but we also have Apple's Siri and Facebook, and we have Google, OK Google. All of those artificial intelligence type applications are considered to have brains and are able to interact with you and I. And my students, more than 5 years ago, they set a program up so these artificial intelligence were arguing with each other. And now we see that IBM's top level programs are not just arguing or debating with each other, but they're able to debate with human people, something that can change the way we live and how we're experiencing things in the world. This idea of deep learning, it's no longer just an academic concept. It's no longer just something that people are researching. It is out there in the world surrounding us now, surrounding almost all businesses. Machine learning is a huge part of it. It became a tangible, useful class of machine learning that would affect our everyday lives. And it's not just a simple thing. It can be with various experimentation and research with exploratory analysis, various analytics that I was suggesting in earlier classes. Get to know the analytics like Facebook analytics, Google analytics. First, it's some of the freest, easiest stuff to start playing with. And then you're going to see more and more intelligent, business intelligent capabilities. There's a lot to it. This slide shows the applications of machine learning, whether it's automatic language translation, medical diagnosis for machine learning with the stock market trading, machine learning for online fraud detection or virtual personal assistants, email spam and malware, self-driving cars. A lot of people are aware of some aspects of self-driving cars, but they might not be aware of some of these other things that are already almost all around us, including product recommendations. And if you do not have the recommendations from data science, you will fall behind the other companies that are working with this data science to know what the customers want and where the customers are. There's a lot of details there. And it keeps going on. So machine learning and artificial intelligence, or AI, they dominated the media, overshadowing every other aspect of data science, like exploratory analysis or experimentation, and the skills we traditionally called business intelligence. So what I'm pointing out here is, although these things are kind of related, some basic concepts like the traditional business intelligence, we don't hear of too much anymore because we're hearing mostly about artificial intelligence or machine learning. And this idea of data science, it's not only machine learning and artificial intelligence. There's a broad spectrum that's involved, whether it's decision making is being sped up. It's getting great benefits. Other benefits are you're using data for a better understanding of business performance. Your KPI response, your key performance indicators are improving. Your comprehensive data visualization. Sometimes in the past, you could have collected data and surveyed a lot of people, but you couldn't actually see what it meant. Nowadays, with this data science, you can have better visualization of these details. And it's connecting different company departments. This idea of the management information systems or ERP systems, customer care, all aspects. It's coming together. And obviously, a big part of it is the idea of the profit increasing. Competition is getting nailed, especially the competitors that don't use this data science. So make sure you're aware of these details. The general public think of data science differently than it may actually be. You may think it's only related to AI or machine learning. And if you don't understand machine learning, or if it's too complicated, maybe you think that you can't work with data science, and that is wrong. You can still work with the business intelligence from simple things, even starting with an Excel file. Make sure you're aware of those details. So with the old style popular jobs, companies like Airbnb or Uber and Google, those are very tech-heavy companies. So they're following the newest tech. They know what is the latest and the greatest technologies that can help them grow. And they're not just using it, they're hiring more and more people, a lot more people. What we see here is Airbnb is hiring a data scientist for analytics in San Francisco. And it explains the job advertisement details. Here is another job advertisement for Uber, the car company, or some people say the transportation company, and they're just collecting information about transportation. They're also looking for a senior data scientist for advanced analytics. And of course, Google is looking for a product analyst, data science. So all over the place, it's growing like crazy. Big companies are aware of it, they're using it, and they're hiring more people than are available right now. So there is a misalignment. It's not only with machine learning or advanced crazy things that you don't understand. Sometimes it's basic things. All of these companies, they have so much information, you can just look at a chart and certain customer trends will pop out at you. And so data science, it is new, and there's a lot of opportunities. So as we said with Google, like Google and Facebook and Netflix, there's so many people using these that the users' usage statistics are pretty easy to see. You can see when people are using it. You can see what's popular. You can see what's trending. You can see what your friends are doing. So the reason for the misalignment is that, yes, most of the data scientists can probably work on more technical problems, more advanced things like machine learning, but these big companies like Google, Facebook, Netflix, they have so much information, so much data already, it's considered low-hanging fruit. And it will improve their product simply by looking at these details. They don't require any advanced machine learning or statistical knowledge to find impacts to help their business. Like we say, this cartoon, low-hanging fruit, people have heard of it, but unless you're actually moving to work with it, it's going to poke you in the eye and be a problem. You must be ready for it. It is here. The more you know, the better, but even simple versions are being valued. Here's another one. For example, the Shopify data science. A question: which users spend the most time on Shopify and why? Method: take the top 90th percentile users in terms of time spent and aggregate their user behavior by activity and compare to the rest of the users. So a result of this, and the insights show they spend a disproportional amount of time on photo uploading for their store because they need to upload multiple images per item since most of them are clothing brands. And an action improves the photo upload process by allowing batch uploads. What am I saying here is pretty important. We're on just slide 24 right now, but slide 31 and 32, I'm going to be asking you to talk about exactly that. So what we're showing here, you need to identify an example of data science. Here's one right here. So data science can help identify what users spend the most time on your company, or what users spend the most time on Shopify or your product, or Google or Facebook or TikTok. And not only that, but why do they spend that much time on it? And it shows methods or the insights and the actions. Company will give you the most ambiguous and sometimes hard problems, and we expect crazy rocket scientists or data scientists will guide the company in the right direction, but it's not that complicated. As I said, again, you can track your users fairly easily, and simply by seeing when the users are looking, that's maybe when you should go online, have your salespeople online to simply answer questions then. Or by seeing what your users prefer with color or size or product and services details, just start providing those variations, what the customers are tending to. And at the same time, your data science will show you what your customers might not like. Obviously, do less of that. So it doesn't need to be rocket science. Start learning these details. Being a good data scientist isn't about how advanced your models are. It's about how much impact you have with your job. It's about how much impact you have with yourself, with your environment, and with obviously your product or service with your company around you. It's not just a data cruncher or coder or hacker. Anybody can be a problem solver now. You're all strategists as long as you're aware of these details. Companies will give you the most ambiguous, hard problems and expect you to guide the company in the right direction. Sometimes it doesn't have to be that hard. So, a brief history of data science we see here. It shows that even as far back as 1962, we had people like John Wilder Turkey expounding on a move in the world statistics. And in 1974, Peter Noer, who I believe was from Denmark, he wrote the Concise Survey of Computer Methods, utilizing the expression data science over and over again, one of the first times it's being used. And then John Wilder Turkey, again, he composed a second paper titled Exploratory Data Analysis, getting more into it. It's not just one person doing it. Sometimes these people are doing it repeatedly, and their colleagues are learning about it. It's growing like crazy. So Greg Shapiro, he arranged knowledge discovery in database workshop in 1994. Business Week ran the main story of database marketing, and Business Week is just a very popular magazine that is used by businessmen around the world, globally. Then we get up to another guy, Jacob Zahavi. I need to know data science to find out what is the proper pronunciation for some names sometimes. Forgive me, but Jacob Zahavi brought up the requirement for new devices to deal with the enormous measures of data accessible to organizations. It went on to the International Council for Science, a committee on data for science and technology, started distributing the Data Science Journal. Hadoop, open source, non-relational database was released. Then the title data scientist turned a trendy expression in the long run, a piece of language. And then data scientists expanded by 15,000% over 10 years ago. And it's still growing like crazy. So again, 15,000% growth from 2011 to 2012, 10 years ago, more than 10 years ago. It is still growing. Be aware of these details. Here's another file from even longer before that, 1996, the idea of data mining, from data mining to knowledge discovery in databases. You can learn so much. What it was saying in this journal article, AI Magazine, was that this idea of KDD, or knowledge discovery in databases, refers to the overall process of discovering useful knowledge from data. And it was growing, that whole idea of data mining and the applications of specific algorithms for extracting patterns from data. That is a big part of the beginning of data science. Next, we go on. So the history of data science, as I said, to clarify it, it's not just with this Harvard Business Review talking about how data scientist is the sexiest job in the 21st century. It started long before that. Harvard is very, very well respected, but we see here that data science went back to 1974 and even before, when, as I said, Peter Nauer from Denmark proposed it as an alternative name for computer science. Then, about 10 years later, in 1985, it started getting very big in China. The Chinese Academy of Sciences in Beijing, Professor Wu used the term data science first as an alternative for statistics. He went on, and 10 years later after that, the International Federation of Classification Societies became the first conference to feature data science. And then shortly after that, because data science was still confusing to most people, the definition was still in flux. By 1997, even though he started in 1985 talking with this Chinese Academy of Sciences, in 1997, CF Jeff Wu suggested statistics should be renamed data science to help the inaccurate stereotypes with the accounting, or limited to describing data. And then again in 1998, Hiyashi Chikyo argued for data science as a new interdisciplinary concept with three aspects. Three core aspects at the time were data design, collection, and analysis. It's still a huge core of what we're dealing with today, but it is developing every day, every week, every month, every year. So back in the 1990s, a popular term for a process of finding patterns in data sets, which was growing, and with the data sets getting very, very big, included knowledge discovery and data mining. Then more recently, 10 years ago, technologist Thomas Davenport and DJ Patil declared in Harvard Business Review, this picture here, that data scientist, the sexiest job of the 21st century. This article, this research journal, was picked up by famous newspapers like the New York Times and the Boston Globe, and that was read by hundreds of thousands or millions of people. And so while scientists started with it, it is now getting out to almost everyone. And this again was more than 10 years ago. It is still exploding and growing like crazy. Make sure you understand data science. It's key to successful management. It's key to target customer analysis. It's key to customer needs analysis and marketing in general. It's the core of successful business, especially with social media and digital marketing. Please understand details. Otherwise, you're going to have problems. So this core of data science, as we can see, it goes from artificial intelligence and deep learning through with experimentations and machine learning algorithms down to what I think is the core in the middle here, in my opinion, is the analytics and the metrics. There's more things like segments and aggregates, features, training data, but this idea of the analytics, as I said, back in the year 2000, huge, rich companies spent millions of dollars for ERP systems, MIS systems to manage the data. But shortly thereafter, analytics programs started to come out for free. And so you have access to free programs that will analyze the data and show you what's happening if you're using it properly. Most people use Facebook incorrectly. They just put up a photo in Facebook and they say a couple of nice words and they think the world is going to appreciate it, but they don't realize that probably it's only going to be seen by your best friends and your mom. If you want the world to see it, and specifically if you want the customers interested in your keyword of your product are interested, you have to use that data science keyword. You have to use those analytics details to identify what are the keywords, where are those customers, when do the customers come, what are the details those customers want to focus on, and you can use that information. And again, this hierarchy of needs, it goes beyond that, from AI and deep learning through analytics in the middle with the metrics to cleaning and exploring the data, to the anomaly detection, to the outliers. Sometimes people say that we can't delete any outliers. Other people want to clean the data and get rid of strange freak data that might be by mistake, making sure that you move and store good quality data, reliable data flow, make sure that you have a good infrastructure, good data pipelines, etc. And of course, how you collect the data. And again, I'm going to finish our talk today talking about how, while there's a lot of definitions and applications of data, you must understand how to, simple details like how to collect it and the ethics behind it can change things. Like, you could be your own enemy to success because you are biased or prejudiced for some things. Like, you are prejudiced, you like to drink water or you like to eat food. Your biases can impact your data. So these details, the hierarchy of needs with data science, it tells companies what's happening with your product and customers. And since you are limited in understanding what's happening in the world, and since you don't usually know what all customers want, using this big data and data science will tell you what to do properly and help you avoid your own biases. So here's a simple image. So data science, it's generally extraction of knowledge and insights from junk data or noisy, unstructured data. So much stuff goes into the internet, so much stuff goes into the cloud that people will get turned around and lost in that information. So you can take data science and extract knowledge and insights from that noisy, unstructured data, and then turn those into knowledge insights, and then turn those insights and reports into actions to help your business. And what we see here is it goes from the noisy data to the knowledge insights to the actions. That's the core aspect that we're looking at, but there's lots related to it. For example, there's data science is in the middle here, with it being central to computer science and mathematics or statistics and business expertise or domain knowledge. But you don't always have to be a computer coder to do it. You don't always have to be a statistician to use it. This is just a simplification. Please learn lots about it. The more you will learn about it, the better your business will become, and the more successful you will be. And there's a lot to learn, like how many different types of data science is there? How many types of data science with complexity and value? There's just, we start with descriptive analytics, simply saying what it looks like, or diagnostic analytics, which is a little bit more complex, a little more valuable, to predictive analytics. And I had students about 10 years ago show how L'Oreal Cosmetics could use data science and social media to predict what the customers want and just stock those cosmetics for the customers in their area. So it increases your profitability enormously when you can predict what the customers want. You don't waste money on things they're not going to buy. And then even more complex and more valuable is the diagnostic analytics or descriptive analytics. There's so much information, and it goes back and forth. The idea, there's business analysts that relate to it. There's data engineers that relate to it and work together with the business analysts. And then there's data scientists, which work with these other specialists. And there's some data scientists, we can call them unicorns. Some of them may be specialists in doing all of it, but there's so much information and so much data to work with. Usually people are Welcome back to today we're talking about Introduction to Data Science for Business. So this is session 3, what really is data science? And I had just gone through the first 30 slides. What really is data science? How does it how was it made? How was it created? The history of it with MySpace, Facebook, YouTube, how it's growing with different apps to create the insights with MapReduce or Hadoop or Spark, how big data and data science are growing in a related way, talking about the Journal of Data Science and how research is definitely not just focused on it, but it's growing, and it's talking about how data science and artificial intelligence is a force for good, for sure. And it's amazing how data science and even small versions of it, like artificial intelligence, can now debate with other human beings. So we talked about all of these things. We talked about how these companies, big companies, many companies are hiring people to work as a data scientist all over the place. Here's an ad from Airbnb trying to hire somebody. Here's another ad from Uber also trying to hire a data scientist, and another ad from Google trying to hire another data scientist. There's lots of growth, lots of opportunity. It doesn't require you to be a computer coder or a data cruncher. All it requires is you to be a problem solver, be a strategist, be a little creative. So we started talking about those, and I just went through and explained this slide before Zoom stopped. So I'm trying to make sure that everything's going okay right now. The main part I will show before I pause the recording is this idea of our assignments. Students in this class, Data Science for Business, our first activity or our assignment activity is for you to list what you think are 5 of the most popular and valuable or useful data science for business related activities, especially activities that may help your future. And try to list good things and bad things about each. So again, list 5 of the most popular, useful valuable data science for business related to you, and list good things and bad things related to them, and then submit your report, submit your assignment into our class Facebook page by Monday, 5 p.m. California time or Pacific time. And the California class page is the Facebook groups/marketing in EA, marketing in East Asia. That's where I'm based right now. Last week, I was in Toronto, Canada. Now I am in East A. This is our class Facebook group, marketing in EA. If there's any problems accessing the Facebook page, you can submit your details, your assignment to me at this email address here, sean.w.watts@gmail.com. Hopefully that is clear and understood, and everybody can have your reports shared online so you can see what your classmates are writing. That is the purpose, to share this information together, to show you some details. And then we can get on to the second activity is related. List keywords related to the Lunar New Year. So if everybody in class starts looking for the same type of keywords, write down keywords that you think relate to the Lunar New Year. And then a separate task is to write down 5 more popular, valuable, useful keywords related to your future area of specialization. If you want to be a rocket scientist, start looking for the popular, valuable, useful keywords related to rocket science. Or if you're selling or researching beautiful flowers, start finding those keywords related to that and start getting experience with 2 different aspects of it. So the first one, everybody in class will look for the same topic. Keyword for something important, something popular, something valuable related to Lunar New Year. And I want to see what you think is important, what you think is a keyword for you. And write that down again in our class Facebook group before this coming Monday, 5 p.m. Pacific time. And write down 5, the most popular, valuable keywords for your future, your job specialization. What do your customers want to know? And the details are explained here. So there's 2 different assignments. The first one is list most popular, valuable, useful data science for business activities in general. And then the next is list keywords related to one topic for everybody in class. Right now, it's the Lunar New Year. January 22nd was the Lunar New Year this year in 2023. And so whether you are aware of the details or not, it's not hard to figure out. The Lunar New Year is when the new year is starting. What do you think is the most popular or valuable or useful keyword related to Lunar New Year in your opinion? Write it down. Talk about good points related to it, bad points related to it, pros and cons of it, and share that information with the class. I want to see how students have different views. The purpose of the activity is to show you how your thoughts differ from others and why specialization and a targeted focus with keywords in proper data science programs is crucial to success. So now that we've said that, I'm going to continue, and I hope the first 30 slides have been recorded okay. I've already gone through it before there's an internet issue. But we've gone through all of this information, the first 30 slides. And then at slide 31 and 32, I gave you assignments. Now I want to get a little bit more practical to help make sure we understand data science for business and practical application. So what is data and where can I get it? Some people may not know. Some people have asked me, what do you mean? What is this data? Am I supposed to say is data or are data? So data is information that comes from everywhere. You should be listening to all of your data, even when it doesn't fit in easily, even when you have anomalies, even when you think there are strange things. And realize that what you think is normal may not be normal for the world, or it may not be normal for your customers. Check that out. Follow DIE. I'm not telling you to die. I'm telling you to follow DIE. And if you are aware, you should be aware that DIE stands for diversity, inclusivity, and equity. So accept diversity with your data around you. Be inclusive. Include all the data that you can around your environment and your product and service. Collect as much as you can. Give equity, give value to all of the data around you. Sometimes the best results will come from things that you think are not important. Everything counts. And only once you're aware of the data science, you will have better results. So, what is data science? There's a few different definitions. So, data science is coding, it's math, it's statistics in applied settings. That is correct. But it's also data science is the analysis of diverse data all by itself, sometimes without statistics. And data science is also just inclusive analysis. So there's several different definitions. Some people think it's just related to these components of the Venn diagram. So data science Venn diagram from Drew Conway. You can get the full details on the website here. But some people think it's related to hacking skills and math and statistical knowledge and substantive expertise. But it's more than that. And so I've defined these and I tried to explain each of these. And at the same time, you don't have to have coding skills to work with data science. And you don't have to have strong statistical skills to work with data science and to reap benefit from it. But if you do have statistical skills and coding skills, you can get even better results. So let's go through and explain this. First thing we see here is computer coding, computer programming, hacking skills. Part of that creates data science when it is combined with math and statistics, the statistical knowledge. That gets into the traditional research when you are looking at the business details that you know well, your domain, your expertise. So your general business knowledge combined with statistics makes your traditional research. But then once you combine it with computer coding and programming or hacking, you can get things like machine learning or like a danger zone that we can explain later. But all of this combined creates the ultimate data science. So for coding, gather your information, prepare your data, check novel sources, check unusual formats. It requires creativity. There's a variety of different types of statistical programs like R, computer programs, or Python, computer programs, computer language. And then there's databases like SQL or command line, bash, or search, regex. There's a lot of different aspects to coding. The more you know about it, the better you will do, but you do not have to know it. You can do data science without being a hacker or computer coder. Same thing with math. It definitely helps to know math. It definitely helps to know the statistical details. A big part of it is with probability and algebra or regression analysis. Definitely regression analysis, factor analysis. Choose your procedures and diagnose problems. The math or statistics will identify, for example, what is the average, or what are the factors that are in that group that are significant. Know some of those details. And then, of course, your general business knowledge, your substantive expertise domain. Your expertise in your field is very, very important. The goals that you have are important. Your methods and your constraints are important. Can you implement your business well? Can you implement the surveying well? All of that stuff is really important. Next, I just wanted to show you tools for coding. For example, here we see that almost 100% of people with coding, they use Java or C or C++. But one of the most popular tools for coding with data science is Python, that we have outlined here in red, and R and SQL. So those are very popular tools for coding. Please be aware of those details, but it's not just coding. There's other things like tools for data science. As we see here, R tools for data science is important. SQL and Python, they're all important. But even such programs, the tools like Microsoft Excel is incredibly valuable. Just using simple programs like that or maps can help get results with data science procedures. So coding is not vital, but comparisons with statistics is popular with data scientists. Simple surveys are often the most valuable and most used for analysis. As I said, the simple Excel program often provides most data for analysis. So, what is important? It's all important. Coding is important, statistics important, your domain knowledge is important. Coders who can do math, statistics, and business, that's most common. And one more time, statistics or statisticians who can code and do business are less common, which may mean higher pay. And in business, people with the business expertise, business people who can code and do numbers, are least common and generally the most highly rewarded. But we should all be working together. Data science is teams working together, whether you're coders, statisticians, business managers, designers, entrepreneurs, and much more. It is complex. There's so much data out there, and you can't just look at it with a numbers 1 + 1. Sometimes it requires being creative, being artistic, having a designer to take the data and put it into visual formats. So what you may be good at, maybe you want to share with somebody else that might be good at something else. If you are good with coding, maybe partner with somebody else that's good with statistics or good with the business details or good with the design. Statistics is usually a popular thing to talk about. It is important, but it is not vital to do great data science. With training, most data scientists are not trained as statisticians. I'll repeat again, data scientists are very, very valuable, but most of those data scientists, they're not trained statisticians. They may not have been trained in regression analysis or factor analysis or the advanced statistics. Same thing, practice. This whole idea of machine learning and big data are not shared with statistics. Context. Data scientists work in different settings. So statistics is not vital. Sometimes, as long as you can practice, maybe machine learning can learn the details on the machine's own, and so you don't need to learn statistics. Sometimes just having access to big data and feeding that into your computer programs might not require a lot of statistics. Like I say, the analytics programs and insights programs will tell you some of the results, even if you don't know the statistics. Same thing with the context. The data scientists working in different settings can get good results even without the statistics. It helps, but you don't need it. So, what is data science? It has rare qualities. Key characteristics: data science characteristics are usually rare. Data science takes unstructured data, then finds order to it. It finds meaning to it, and it finds value in the data, telling you what product is good, what product is bad, what color, what temperature, what price, what location helps. And the data science characteristics, one key characteristic is it's in high demand. Data science provides insights and competitive advantage. So clearly it is in very high demand. This is a report, even from several years ago. One of the world's best consulting firms is identifying big data is the next frontier for innovation, competition, and productivity. And it's going through, and it's actually what we're saying here. I'm just going to skip to the next part. This bottom box here, it was saying up to 190,000 more deep analytical talent jobs or positions are needed. And much more than that, 7 times more. So almost 200,000 jobs are needed for deep analytical analysts, but 1.5 million more data savvy managers are needed to take full advantage of big data in the United States. So again, this data is growing increasingly valued, increasingly valuable, increasingly well known, but there's not enough people to do the work. There's not enough people for those jobs. And this was over 10 years ago, and it's still growing. So big data is a growing torrent. 600 to buy a disk drive that can store all of the world's music. 5 billion mobile phones in use in a decade ago, 2010. 30 billion pieces of content shared on Facebook every month. Again, that's very old information. 30 billion is an incredible big number. And so Facebook is getting a crazy amount of data. 30 billion pieces of data going into Facebook every month. 10 years ago, more than 10 years ago. Now it's much, much more than that. So be aware of that. Work with this data. 40% of projected growth in global data generated per year versus 5% growth in just global IT spending. It seems to me pretty obvious. So feel free to send me an email, send me a text message. You have a lot of my contacts. My contacts are at the bottom here. Sean.w.watts@gmail.com. My phone numbers are here to contact me by WhatsApp. Again, my Zoom contacts, Facebook contacts, WhatsApp, Kakao in Korea, email, phone numbers, LinkedIn, Skype, and with Facebook, we have a class page. You can make some notes and contact me that way, or you can contact directly the teaching assistant, and he will help explain the important parts of the class and what is required, especially, as we said here, the assignment activity 1 and assignment activity 2. Make sure those are clear to you. We went through the tools for coding, like Python is popular, R, SQL is popular. They're still here as tools for data science, but they don't have to be complex. Excel is also a tool that's very valuable, as is Tableau and Hadoop. All of these are important to data science: coding, statistics, domain. Statistics not vital. You know, the training was explained, the practice, the context was explained. These could be quiz questions, so be aware. As I said, data science has rare qualities and it's in high demand. Be aware of that. We were talking about one of the world's fanciest consulting companies, McKinsey and Company Consulting. They're promoting reports to their clients and to the world, showing what's important in their opinion, which is very, very valued, showing that innovations and competition and productivity with big data is crucial. How many jobs are there? How much information is there? Just checking the value 10 years ago, over 10 years ago, $300 billion annual value to United States healthcare, more than double the amount in Spain, or $250 billion total annual value to Europe's public sector administration, more than the GDP of Greece, or $600 billion potential annual consumer surplus from using personal location data, or 60% is the potential increase in retailers' operating margins possible with big data. So even the last statement, let's take a look at it. Make sure you understand what we're showing here. Stores selling something. Store selling this shirt. They might sell it for $100, but if they start working with big data, that store may have a 60% potential increase in their operating margins if they're using big data. So please be aware of this potential. LinkedIn, you should also be very well aware of LinkedIn and be promoting yourself in LinkedIn. Here is a professional LinkedIn story saying the 25 hottest skills that got people hired, again, a decade ago. Again, the 25 hottest skills, not just in 2014, but almost for the last 10 years, has been statistical analysis and data mining. And that was the highest in Canada, Australia, Brazil, France, India, Netherlands, South Africa, United Arab Emirates, United Kingdom, many, many countries. And if we keep looking through it, we also see that business intelligence, number 6. Some people say it's the same thing. It's related. So make sure you understand business intelligence. Make sure you're understanding statistical analysis, data mining, and the new term is data science. Know your analytics programs, your insights programs. So what is the path? The first path is planning. Make sure you're understanding and planning very well. The second focus is for data preparation. The third is your data modeling, data science modeling. And then the fourth, follow-up, check the details. So let's explain some of these things. So the first thing is planning. What does that mean? Within planning, there's 4 different sections. Starting, make sure for proper planning, you need to define your goals. Be as specific as possible. The first thing you need to do is you need to define the goals of your project so you know how to use your resources well. Next, Second, organize your resources so that you might have had, let me just make sure that's clear here. You might have data from several different sources. Organize details. You might have different software packages. Maybe you have different people working with you. Make sure you organize details so it does not get corrupted. Next step with planning is to coordinate the people, which gets us to the third one. You need to coordinate the people so that they can work together productively. If you're doing a handoff, it needs to be clear who is going to do what and how their work is going to do together. Next, after coordinating the people, you'll get into data preparation. The next is the data preparation, where you're taking it like food prep. You're going to get the raw ingredients ready before you cook. The first course is you need to get the data, and it can come from many different sources and be from many different formats. Next, data prep. After you get the data, you need to clean the data. And this, the sad thing is, this tends to be a large part of the data science project. A lot of people can get data. You can survey people easily. Walking out on the street, handing out a piece of paper, asking them to fill in the blanks, some people say is a good survey, but you forget that is biased and you're only surveying people that are in your type of conditions, people that live near you, people that work near you. There may be people that are living a completely different lifestyle or with much more money or much less money than you. So you're ignoring them. You're only surveying dirty data. So that's what we mean when we say you have to have clean data. Clean the data. It's a big part of data science projects. You're bringing in unusual data from a lot of different places. You also want to explore the data. That is, really see what it looks like. How many people are in each group? What is the shape of the distributions? And what is associated with each? Next, after number 5, getting the data. Number 6, cleaning the data. Number 7 is explore the data. That is, really see what it looks like. How many people are in each group? What's the shape of the distributions? What is associated with each distribution? Next, refine the data. You may need to refine the data, and that means choosing variables to include, choosing cases to include or exclude, and making any transformations to the data you need to do. Modeling. We're going to be going through several different details here. Create their model. The third group is modeling or statistical modeling. It's where they actually want to create the statistical model. For instance, you might do a regression analysis, or you might do a neural network for creating the model. Validate the model, make sure it doesn't match, make sure it does match your location and your statistical environment. But whatever you do, once you create your model, you have to validate the model. You might do that with a holdout validation. You might do it really with a very small replication if you can. Modeling. Next, evaluate the details. So as we saw here, you can read some of these details. Make sure you're going through and checking these details. So as we said, the next step is that you also need to evaluate the model. Once you know what the model is and it's accurate, what does it actually mean and what does it tell you? Then after you evaluate it, the 12th step is to refine the model. Finally, you need to refine the model. For instance, there may be variables you want to throw out, or maybe additional ones you want to include. You may want to, again, transform some of the data so that it's easier to interpret and apply for your purpose or your business or your product or service, whatever the case may be. Then follow up, present the model, present it to the sales team, marketing team, executives in the company. The last part of our data science pathway is once you've created your model, you need to present the model, because it is usually work that is being done for a client, or it could be in-house inside your company, or it could be to a third party, but you need to present it to those people. Not that many people know how to do the data science work. If you can, you will be valued very much. After you present it, you can deploy it. It's usually being done in order to accomplish something. So for instance, if you're working with e-commerce site, you may be developing a recommendation engine that says people who bought this and this might buy this. So you can say certain customers may buy a certain product or service. You need to actually stick it on the website and see if it works the way that you expect it to. Test your theories. 15, revisit it, check the details. Because a lot of the times the data that you worked on is not necessarily all of the data. Sometimes, as I said, you may be biased. You only surveyed people around your home, and so you're only surveying people with the same educational background or financial background, not the true target customers, the true population, for example. So check with the real world how things are going. See how well your model's working. Last, archive your assets. Be thorough. You need to archive and save your assets. Document what you have. Make it possible for you or for others to repeat the analysis in the future. You start by showing how the company is, your business is, your product and service sales are, and then you develop some data science reports. And if things start to change, if sales start to increase, profitability starts to increase, but you don't save your results, people can say that it wasn't related to you. So save those details to show them. So next, we're going to be looking at the different roles, the jobs, the roles in data science. There are engineers, there are big data workers, there's researchers, there's analysts, there's a variety. So with the engineers, they focus on the back-end hardware and software. It makes the data science possible. Big data focus on computer science and math, machine learning. Data products. Obviously, there's an enormous amount of data. It's just the computer science and math. It's much better when you are combining big data to some organization, to a product, to a service, to a business expertise. So combine them together. But big data, there are specialists just working in that. There are other specialists that are just focused on collecting the research, managing the research. Researchers focus on the domain-specific research, the physics, the genetics, the strong statistics. And of course, analysts, they have day-to-day tasks. There's web analytics that I think everybody should be using in our class, and SQL. Analysts are very good for business. Some people say it's not exactly data science. I can argue that it is. Make sure that you're aware that you should be working as a team, and find out what you're focusing on. Are you focusing on the business, like the frames business relevant question? Business workers manage the projects related to the data science. Business workers must speak data to be effective. And then there's other workers that are focused on the entrepreneurs, data science for the entrepreneurs. So data startups or data some entrepreneurs, they need the data and business skills, and they have creative throughout. The last thing I'd like to start pointing out before I review final details is there are many other things to learn, and we are just getting our toes wet. We're just dipping our toes in the water, testing out some of the details. Make sure you understand it is valuable, it is growing, it pays incredibly well, from $95,000 to $195,000, $200,000 for data science jobs. In addition to everything that we've said earlier, you also have to respect privacy and copyright or anonymity or your biases and overconfidence. So let's go through some of these things. What do we mean? How is privacy related to data science? Sometimes you have to keep things confidential. You survey somebody, maybe you take photos of some people trying to find out what does the perfect customer look like. Some customers don't want their photos shared with other people, such as medical doctors. They don't want to have their medical history shared with the world. Some sources are not intended for sharing, like medical records, for example. Next, copyright. Scrapping data is common and useful. You can get information from web pages, you can get information from PDFs, images, audio, etc. But when you get that information, when you scrape data from easy accessible sources, you need to check, do you have permission to use it? Do you have copyright? So check the copyright. Another thing, before I talk about the last two big ones, anonymity. So sometimes it's not hard to identify who you surveyed or what are the details. Some people want to keep, for example, details private. A good example is their medical records. They don't want to tell somebody, oh, I have diabetes or epilepsy or some possibly fatal illness. So HIPAA, which stands for the Health Insurance Portability and Accountability Act, the law, is talking about there is protected health information. You must respect protected health information and must remain anonymous. Next, there's proprietary data that may have identifiers. Some drug companies just want to keep details confidential to themselves so they can reap the benefit, not others. Next, we're getting into some of the last things we're going to talk about, most interesting things we're going to be talking about. Data. We're talking about managing data, how you can be successful with business. And the answer is try to become a data scientist. Try to work with data science. But understand you, whoever you are, Tom, Dick, or Jane, you are probably one of your biggest problems. You are probably very biased. You like water, so you're saying water is good. Well, I live in a place where a lot of the water in the country has been poisoned because of a war. So we can't easily drink water here unless you're paying quite a lot of money for it. That's just an example. There are potential biases. There are algorithms that are only as neutral as the rules and the data that they get. So whoever is creating the data science algorithms, if you have a bias, all of your results are going to be biased. Some people say that a lot of the medical records are biased because they were surveying mostly European men. And that turned out to be mostly white men. And so perhaps people from other ethnic backgrounds don't have the same medical background or health background. So there's biases in many things. Check how you're biased. Just assume you are biased. try to manage the details. And next, if you are aware of data science, you're probably better educated than the average person. And if you are better educated and you are working with data science, you're probably going to be more successful and more profitable than your other competitors. And what happens with that is automatically you may be getting too confident. If you do get overconfidence, analyses are limited to simplifications. They still need humans in the loop. If you think things are good, you may tell everybody things are good, even if the data shows they're not. If you think things are bad, like we're going into a recession or something, maybe you're going to be telling people things are bad, even though there's more and more buyers coming. So be aware of these details. And lastly, before I close up, I just wanted to do a review of one of the big parts of session 2. We started in session 2 talking about how data scientists work a lot with analytics programs, and analytics programs can help you develop your business. And these are tips when working with data science, specifically for social media and digital marketing. These are tactics to get more views or more customers, more subscribers, and more traffic to your website. And so I just wanted to point out here, our assignment on slide 30 and 31 was to work with the keywords. And now you should be starting to understand the value of keywords. It's incredibly important. Make sure you know how to find and leverage your keywords. Make sure you understand how to optimize your video title. For example, put a keyword into it, make it clear, make it a sentence. Don't just make it, jump from one strange keyword to another. Some of the algorithms will detect it's not smooth and may disqualify you. So optimize the video title, optimize your YouTube tags and your content words, ask people to comment, ask them to like, ask them to subscribe. That will definitely help you a lot. Encourage people to subscribe for sure. The more somebody does related to your activities online, the more the big data will see. If somebody just does a like or a wink wink at whatever your activity is, if you put a photo in Facebook and they just give you a thumbs up, that's easy. It's not really doing too much. It's not committing too much. It's not talking about what you like. It could be, in some countries, a thumbs up is actually a swear word. It's a bad thing. So it's simple. It's better if you actually comment and say, good job, which obviously means usually good, unless it's sarcastic. If you subscribe to the person, that's even better. That's why they are encouraging people to subscribe. If you have more subscribers, data science will show you have better results than others, and the system will promote you. Next, step up your production value. Use good equipment. Don't just jump around. Don't just have your camera falling all over the place or shaking or vibrating. And use good pictures, use good thumbnails. Catching somebody's attention is usually done within a very few seconds. If you have a boring first image or thumbnail, for the first 5 to 10, 15 seconds, you will get many people leaving. You will get a lot worse results. So create an eye-catching thumbnail that will attract people, and add closed captions. Edit your file name to improve your search engine optimization. Build links to your YouTube channel, not just for your videos, but to other businesses or other influencers, and try to get influencers to give links back to you. Trade some of those details. That will help a lot. Lots of things to do. Steal keywords from other competitors. Steal keyword ideas to improve your search engine optimization. Start your description with your focused keyword. Use YouTube for keyword research. Learn about it. Increase your watch time. The more that you watch your details, the better it will get. Look at the audience returning, visiting reports. Check the engagement reports. Add some suspense to improve your video or your online activities, for example. So I'm just reading these things. We explained these in session 2. I just want to make sure that you're aware of these. These are very important. They will be on the quiz at the end. But our assignment here, talking about keywords, is showing exactly that, which is assignment activity number 1. Talk about the 5 most popular and valuable, useful data science for business related activities. So what are data science for business activities? List 5 of the most popular, valuable, useful data science for business activities. Try to say good things and bad things about each. Submit that quickly to the Facebook group or to the email. And the second activity is to do the same type of thing. List the keywords for 2 different topics. List keywords for the Lunar New Year. And if everybody in our group, everybody in the class lists what they think are keywords, I want you all to see that other people will have other results. That's why you need big data. That's why you need data science. Next, after you have identified what are data science activities and you've identified the importance of keywords and how to get keywords, start trying to develop your future job specialization keywords and continue focusing and developing that. And hand that in before Monday, 5 p.m. Pacific time in the Facebook /groups/marketing in EA. Or you can email it to me at sean.w.watts@gmail.com. With that said, we've gone through all 70 slides today. Please submit all of these details. Stay in touch. Contact me anytime. I'm available to clarify details with our class and outside of the class. Our class is with Western Covenant University every Tuesday at 6:30 p.m. to 10:30 p.m. Pacific time, California time, Tuesdays. If you're in other countries, convert the time zone and be ready, and then sign up to the Western Covenant University as students, and you can log in to those groups. Thank you very much, folks. Hope you have a good day. Happy Lunar New Year.